We're just going to be going over some low pass, high pass, band pass, and band reject. These are notes found in EEE 117 network analysis. This was the class before this, so the material before this, but the material that we're working on now is kind of very familiar to the previous stuff, so that's why we're going over it. So a low pass filter selects low frequencies between 0 and the corner frequency, and for the passband. One implementation of a low pass filter is the RL circuit. Now, it says RL right here, but when I look at it, I like to think of it as LR. And that's because we could use the voltage divider to figure this out, but when we have low pass filter, like how we have here, I think of the L on top and then the R on this. And for high pass, which we're going to go over in a second, it's opposite, where R is on top and L, if we had an inductor, is with our voltage right here. So an easy way to remember this is low pass filter. We have our L for low. They're saying it starts with the same thing. L's on top, and then our resistor has to go on the bottom here. And then we have some more information about this here. But if we scroll down, there is another type of low pass filter, and that is not with the inductor and the resistor. Instead, it is with a resistor and a capacitor. So when I think of this one, I say, okay, well, we have our inductor up top, and then we have a resistor down here. And so if we have a capacitor now, it's going to be the opposite, where the resistor is going to be up top and the capacitor is going to be down here with the voltage. And that is how we would look at low pass filters. Now we're going to look at high pass filters. With high pass filters, it's a little bit different. So we have our RL and then the CR. We can see it's the same kind of principle where it's switched depending if we have an inductor or a capacitor. Now for this one, I say, okay, well, we've gone over low pass filter and we know that the inductor is on the top for low pass. So for high pass, the resistor is on the top and the inductor is on the side. And that means if we flip it, that means if we have a capacitor, the capacitor has to be on top and the resistor is on the side. And so that's how we would look at high pass filters. And this is just some more information about high pass filter. And this can be found in the notes, in the description, linked below the like button. There's also bandpass filters, and this is where the bandpass filter allows a limited region of frequencies to pass through our filter. And we have some formulas and how it looks like right here. So the series RLC circuit acts as a bandpass. Now for bandpass and band reject, we are going to have series and parallel. So for bandpass, we're allowing things through. We have an inductor and a capacitor here. So when our omega is equal to 0, the capacitor acts as an open circuit and the inductor acts as a short circuit. So no current is going to flow through our resistor R when the voltage is at 0. And then at high frequencies, the inductor acts as a open circuit. So at low frequencies, the capacitor is an open circuit. High frequencies, the inductor is a lower circuit. So still, the resistor will have no current flowing through it. But the specific point of this is to see that whenever we have band pass, we have a pass where our inductor and capacitor are up top. So that's how I like to think of it, band pass. We have inductor and capacitor up top. And that's an easy way to remember how to draw that. And we can see that we have inductor and capacitor here as well. And this is just some more examples on how to solve it. We have the parallel form now. And the parallel form, it's a little bit different. You can kind of see the same way where it's opposite because, well, in the band pass that we just went over, when it's in series, we know our inductor and our capacitor are up top, right? So just like the previous high pass and low pass, let's switch it around. So instead of the resistor being over here, the resistor is going to be up top. And since it's in a parallel form, our capacitor or inductor are just going to be in parallel with each other. And the C comes before the L, so the capacitor is here and the inductor is here. Now, we're lastly going to look at the band reject filters. And the band reject filter passes source voltages outside the band between two cutoff frequencies. So we have pass band, stop band, and then a pass band here. The important part is our circuit. So for band pass, we know that we had something that looked like this where we had LC up top. So band reject, you can think of it as the opposite. We are not passing, we're rejecting. Just like low pass and high pass are kind of opposites of each other. So for this, our resistor is going to be up top, and since it's in series, our inductor and our capacitor are going to be on the side with our voltage. Now, for low frequencies, the capacitor we know is an open circuit, and for high frequencies, our inductor is an open circuit. So if we scroll down, we are going to be able to find the parallel form. The parallel form, it's very, very simple, where we're just going to kind of swap the resistor with our capacitor and our inductor. So the resistor is going to go on the side, and our capacitor and inductor are up top. However, since it's in parallel, they're going to be in parallel with each other just like this. And that is the difference between our low pass, high pass, band pass, and band reject filters.